Today we're going to be talking about the Poisson distribution, which is given right here and written down with probability density function. And we should note that the formula in this box applies for any x values starting at 0 and increasing from there on. So I could have just written x greater than or equal to 0. So a common situation in the Poisson distribution is that you're given a rate or an average. And this is important because you need to be able to identify which distribution to use. And one of the key words is that you're required to know a rate or also average or expected value. Okay, it turns out that here the parameter k represents the average or the rate of occurrence. It turns out that the expected value of Poisson distribution is actually k in that formula. So let's answer 1. In this scenario, we're asked what's the probability more than one tornado occurs in a 9-month period. So here I'm going to set my random variable x equal to the number of tornadoes in a 9-month period. Now I told you that k in the formula in the box above represents the rate of occurrence. So here it says in the problem tornadoes occur at a rate of twice every 9 months. So 2 tornadoes every 9 months. So that's 2/9. That's what we'll use. And the 2 represents two tornadoes, the 9 represents the 9 months. Okay. So if we're asked to calculate this probability, we're asked to calculate probability that more than one tornado occurs. So the probability x is greater than 0, which will be 1 minus the probability, I said it, but wrote 0. This should be the probability x is bigger than 1, more than one tornado. And using the complement rule, it would be that probability, which of course corresponds to the possibilities that x is 0 minus the probability x is 1. Okay, now that we have these probabilities, we know the value of k. All that's left is to use the formula in that box. So this will be 1 minus, and this will be e to the minus k times k to the x divided by x factorial. And the value of x is given in the probability below. So this will be e to the minus 2/9 times by 2/9 to the 0th power, which is 1, divided by 0 factorial. And remember, 0 factorial is 1, minus e to the minus 2/9 times by 2/9 divided by 1 factorial. So we can simplify this. This will be 1 minus e to the minus 2/9 minus 2/9 times e to the minus 2/9. Then you just need to calculate this number to get probability. And let's just calculate this number very quickly. And this will be a very small number, it should be about 0.021. Okay. Now, in this second question, it asks, what's the probability more than one tornado occurs in a 6-month period? Here I want to highlight the difference is that it's asking for a different time period. It's asking for a 6-month period, not a 9-month period. So the answer to 2 is, well, we need to change our random variable x. It needs to be the number of tornadoes in a 6-month period. And we need the parameter k to be the number of tornadoes that matches the random variable, that matches this 6-month period. But we have a slight problem. We were given k to be 2 tornadoes every 9 months. So we need to convert this not into a 9-month period, but into a 6-month period. So we have to multiply by a unitless quantity. I'm going to multiply by 6 over 6. Now, I'm going to view this as 12 ninths of a tornado divided by 6 months. Okay. All I did was some simple algebra here, and I needed to multiply by the unitless quantity 6 over 6. The quantity that I'm looking at for k is 12 ninths now, and that's how it's changed. Okay. So if I want to calculate this probability that x is bigger than 1, we'll go through the same steps, and we'll use the complement rule, calculate 1 minus probability x is 0 and 1 minus probability x is 1. And we will use the formula, because we know that this is Poisson, we'll use that formula in the box right there, but we'll use a different value of k. So this will be 1 minus e to the minus 12 ninths times 12 ninths to the 0th over 0 factorial minus e to the minus 12 ninths times by 12 ninths to the first power divided by 1 factorial. Then we just need to calculate what this is. And we should get 0.38. Okay. So this is just a little example of using the Poisson distribution, and a couple key takeaways is, first, not only this formula in the box, but also identifying k. One of the key characteristics of a Poisson distribution is that the parameter k needs to be given in the problem, needs to be a rate or an average or expressed in a synonymous term. The second thing is that it's really important to identify the units or the rate of occurrence that you're asked to calculate the probability of, whether it's 9 months or 6 months. And finally, a key critical component is just in writing down the random variable can be super useful. Notice here that, x is not confined to be less than a set number. So it could be 0, it could be a really large number, x could be the number of occurrences. So it could be a really large number like 1,000 or 10,000, and the probability of 10,000 would be a very small probability. Okay, thank you very much.